Welcome to Deep Space Explained, the channel where we journey across the cosmos from our planetary backyard to the most distant edges of the universe. Here, we unravel the mysteries of space, time, and everything in between, with science, storytelling, and a touch of cosmic wonder. Have you ever dreamed of traveling through time, going to the future to witness the destiny of humanity? Or returning to the past to change a choice, prevent a tragedy, or meet your ancestors? Since childhood, we've been fascinated by this idea. It appears in movies, series, books, and in some of science's deepest questions. Time travel is one of the subjects that most blend science and philosophy because it touches the essence of reality. What is time, after all? Albert Einstein revolutionized our understanding of time by showing that it is not absolute. Time is part of a greater structure called space-time, which unites the three dimensions of space with the dimension of time. The faster you move, the slower time passes for you, and the stronger the gravity, the more time drags. This has been measured with atomic clocks at different altitudes, confirming that time is elastic, shaped by speed and gravity. Traveling to the future is already possible on small scales. Experiments have shown that clocks on airplanes and satellites tick differently compared to those on Earth. The GPS system only works because we correct these time differences. Astronauts also experience this effect. They age slightly less than us down here. It's a small difference, but it's real. This means the future can already be reached, although slowly. Black holes are regions of extreme gravity where time nearly freezes. An astronaut near a black hole could experience hours while decades pass for someone far away. Wormholes, on the other hand, are mathematical solutions that could connect two different points in space-time. They would be like cosmic bridges, able to link not only distant places but also different times. The problem is they would be unstable and would require a kind of exotic matter that has never been found. Traveling to the past is far more problematic. The famous grandfather paradox illustrates this. If you prevent your grandparents from meeting, you would never be born. But if you were never born, how could you have traveled back in time? Another paradox is causality, when an effect creates its own cause. Some physicists suggest the universe does not allow paradoxes, and that everything you do in the past is already accounted for. Others defend the multiverse idea, where every change creates a parallel timeline. In the quantum world, time seems to behave even more strangely. In the double-slit experiment, the simple choice to observe a particle appears to influence its past. Quantum entanglement shows that two particles can react instantly regardless of distance, as if ignoring time itself. Some scientists believe time may not be fundamental, but merely an emergent phenomenon of quantum physics. Philosophy also questions the nature of time. Presentism claims that only the present exists, while eternalism argues that past, present, and future all exist equally, like frames of a movie. If eternalism is correct, traveling through time wouldn't mean creating new events, but rather accessing frames that already exist. This raises deep reflections. Is our destiny already written, or are we truly free to build our own path? The future of time travel is still a mystery. Perhaps our technology will never be able to manipulate space-time in such a way. But civilizations far more advanced, on higher levels of the Kardashev scale, could have that capability. Some even speculate that if time travel were real, travelers might already be among us. Yet the absence of evidence may itself be proof that the past is inaccessible. The scientific frontier of time travel lies in theories we are only beginning to understand. Concepts like closed time-like curves, exotic matter, and quantum gravity are explored on the edges of modern physics. These ideas suggest that under the right conditions, space-time itself could loop back on itself. Yet, each possibility runs into enormous technical and energy barriers that we cannot yet overcome. Still, what seems impossible today might one day be as natural as electricity or spaceflight once were. The future of time travel also raises profound philosophical questions. If we gain the power to move through time, will history remain fixed, or will it splinter into infinite branches? These questions go beyond physics. They touch the meaning of free will, destiny, and our place in the universe. The search for time travel is not only about machines, but about understanding the true nature of existence itself. Even if we never manage to travel through time, we are already travelers. We are always moving forward into the future, 1 second at a time. Time is the most precious resource we have, because it is irreversible. We cannot go back, and that is what gives life meaning. Valuing the present is our way of mastering time. It doesn't matter if time travel never becomes real. What matters is how we choose to live the time we already have. So, is time travel possible? Science has already shown that yes, at least into the future on small scales. But the past remains a territory full of paradoxes. Perhaps in the future, we will find new answers. Until then, the greatest journey we can make is to cherish every moment of our lives. If you enjoyed this dive into the cosmos and philosophy, give this video a like, subscribe to the channel, and turn on the notification bell.